In the heart of the digital revolution, a staggering 62 million tons of electronic waste were generated globally in 2022, with only 3% being formally collected and recycled. This staggering figure is not just a statistic, it represents a crisis that threatens the very foundation of our planet. The rapid exponential increase in e-waste is a direct result of our consumption-driven society, where frequent new model releases and short innovation cycles have become the norm. But what's driving this insatiable demand for new electronics, and what are the consequences of our actions? As we delve deeper into the world of e-waste, we find that the problem is far more complex than just discarded devices. The production and disposal of electronics have severe environmental and health implications. Electronic scrap components, such as CPUs, contain potentially harmful materials like lead, cadmium, and beryllium, which can have devastating effects on human health and the environment. The informal processing of e-waste in developing countries has led to adverse human health effects and environmental pollution, highlighting the need for urgent action. But the story doesn't end there. The environmental impact of the tech industry extends far beyond e-waste. The design, training, deployment, and use of artificial intelligence have significant greenhouse gas emissions, operational and upstream water use, and material impacts from hardware manufacturing, mining, and electronic waste. Estimating AI's environmental effects can be difficult, but one thing is clear: the energy use associated with AI is substantial. From model training to inference, storage, and networking, the carbon footprint of AI is a pressing concern. A benchmark study presented at the 2024 ACM Conference on Fairness, Accountability, and Transparency found that simple classification tasks consumed about 0.002 007 WH per prompt on average, while image generation averaged 2.91 WH per prompt. As we explore the world of AI, we find that the energy use per AI request varies widely across models, tasks, and measurement methods. A 2025 Google study on Gemini Assistant Serving reported a median per-prompt energy estimate of about 0.24 WH, roughly equivalent to watching 9 seconds of television. But what's striking is that software and infrastructure improvements reduced energy use by a factor of 33 and carbon emissions by a factor of 44 for a typical prompt over 1 year. This raises an important question. Can we replicate this success across the entire tech industry, or are there more complex factors at play? The story takes a darker turn when we consider the environmental impact of Bitcoin. The process of Bitcoin mining is energy-consuming and results in carbon emissions, with surveyed miners reporting that 48% of their electricity comes from fossil fuels and 52% from sustainable energy sources. The use of specialized computer hardware that physically degrades through use has led to a significant amount of electronic waste. As of 2025, several empirical studies have reported an association between higher Bitcoin mining electricity use and worse environmental sustainability indicators. But that wasn't the strangest part. The Cambridge Center for Alternative Finance estimated that Bitcoin consumed 138 TWh of electricity annually, representing 0.5% of the world's electricity consumption and resulting in annual greenhouse gas emissions of 39.8 mt CO2. As we navigate the complex web of e-waste, AI, and Bitcoin, we begin to realize that the environmental impact of the tech industry is far more intricate than we initially thought. The rapid growth of e-waste, the energy-intensive nature of AI and Bitcoin, and the lack of transparency in the industry have created a perfect storm of environmental degradation. But what's driving this storm, and how can we mitigate its effects? The answer lies in the intersection of technology, policy, and human behavior. As we move forward, we must confront the harsh reality of our actions and work towards a more sustainable future. The question is, are we ready to face the truth and take action, or will we continue to bury our heads in the sand, ignoring the devastating consequences of our addiction to technology? As we delve deeper into the world of e-waste, it becomes clear that the problem is far more complex than initially meets the eye. The sheer volume of electronic waste generated globally is staggering, with approximately 62 million tons produced in 2022 alone. But what's even more alarming is that only 3% of this waste is formally collected and recycled, leaving a vast amount of toxic materials to pollute our environment. The European Union's classification of e-waste into 10 categories, including used electronics destined for reuse, resale, salvage, recycling, or disposal, highlights the scope of the issue. But despite these efforts, the rapid exponential increase in e-waste continues to pose a significant threat to human health and the environment. One of the primary drivers of this crisis is the frequent release of new electronic models, which renders older ones obsolete and destined for the scrap heap. This culture of disposability is perpetuated by the tech industry's emphasis on innovation and profit over sustainability. The consequences are dire, with electronic scrap components containing hazardous materials like lead, cadmium, and brominated flame retardants. Recycling and disposing of these materials pose significant risks to workers and their communities, particularly in developing countries where informal processing of e-waste is common. But that's not the only factor contributing to the e-waste crisis. The rise of cryptocurrencies like Bitcoin has also played a significant role in exacerbating the problem. The environmental impact of Bitcoin mining is a topic of growing concern, with the process of creating new Bitcoins requiring massive amounts of energy. According to the Cambridge Center for Alternative Finance, Bitcoin mining consumes around 138 TWh of electricity annually, resulting in greenhouse gas emissions of 39.8 mt/co2. This is comparable to the emissions of a small country like Slovakia. But what's even more striking is the shift in Bitcoin mining operations from China to other countries, particularly the United States, Kazakhstan, and Russia. This shift has led to an increase in Bitcoin's carbon footprint, as miners in these countries rely on coal resources with high carbon content. The use of renewable energy sources, like hydropower, is not always a viable option, and the lack of transparency in Bitcoin mining operations makes it difficult to track energy consumption and carbon emissions. As we explore the intersection of e-waste and cryptocurrency, it becomes clear that the two are intimately connected. The rapid obsolescence of mining hardware, which physically degrades through use, contributes to the already staggering amounts of electronic waste. But the environmental impact of Bitcoin goes beyond just e-waste. The energy-intensive process of mining Bitcoins requires massive amounts of electricity, which is often generated by fossil fuels. This not only contributes to greenhouse gas emissions, but also perpetuates our reliance on non-renewable energy sources. But there may be a glimmer of hope on the horizon. A 2023 study found that using Bitcoin mining at planned renewable energy installations in the United States could have potential economic benefits. This raises an intriguing question. Could Bitcoin mining be a catalyst for the adoption of renewable energy sources, or will it continue to exacerbate the environmental crisis? As we consider the complexities of the e-waste crisis and the environmental impact of Bitcoin, it's clear that there are no easy solutions. The tech industry's emphasis on innovation and profit must be balanced with a commitment to sustainability and environmental responsibility. But that's not the only challenge we face. The lack of transparency in Bitcoin mining operations, combined with the rapid pace of technological advancements, makes it difficult to track the environmental impact of these activities. The shift in Bitcoin mining operations from one country to another, often in pursuit of cheap energy sources, only adds to the complexity of the issue. But that's not the strangest part. The fact that Bitcoin mining can be done anywhere, at any time, using specialized hardware, raises questions about the very nature of work and energy consumption in the digital age. As we move forward, it's essential to consider the broader implications of our actions and the consequences of our addiction to technology. The question is, can we find a way to balance our desire for innovation and progress with the need to protect the environment, or will we continue to prioritize short-term gains over long-term sustainability? As we delve deeper into the world of technology and its environmental implications, it becomes increasingly clear that the issue of e-waste is far more complex than initially meets the eye. The rapid pace of innovation in the tech industry has led to a culture of disposability, where devices are frequently replaced and discarded, resulting in a staggering amount of electronic waste. In 2022, a staggering 62 million tons of e-waste were generated globally, with only 22.3% being formally collected and recycled. But that's not the most alarming part. The rate at which e-waste is growing is projected to reach 82 million tons by 2030, making it one of the fastest-growing waste streams in the world. The environmental impact of e-waste is multifaceted, with potentially harmful materials such as lead, cadmium, and brominated flame retardants being released into the environment during the recycling and disposal process. The European Union has classified e-waste into 10 categories, including used electronics destined for reuse, resale, salvage, recycling, or disposal. However, the lack of standardization in e-waste management has led to a significant risk to the health of workers and their communities, particularly in developing countries where informal processing of e-waste is common. But what's even more concerning is the role that Bitcoin mining plays in exacerbating the e-waste problem. Bitcoin mining, the process by which Bitcoins are created and transactions are finalized, is a highly electricity-intensive process that results in significant greenhouse gas emissions and electronic waste. According to the 2025 Cambridge Digital Mining Industry Report, surveyed miners reported that 48% of their electricity came from fossil fuels, while 52% came from sustainable energy sources. However, the physical degradation of specialized computer hardware used for Bitcoin mining has resulted in a substantial amount of e-waste. In fact, several empirical studies have reported an association between higher Bitcoin mining electricity use and worse environmental sustainability indicators. But that wasn't the strangest part. A 2023 study found that Bitcoin mining could potentially be used to utilize excess energy from renewable sources, highlighting the complexities of the issue. As we explore the environmental impact of Bitcoin mining, it becomes clear that the issue is far more nuanced than initially thought. On one hand, the energy-intensive process of Bitcoin mining has led to significant greenhouse gas emissions, with the Cambridge Center for Alternative Finance estimating that Bitcoin consumed 138 TWh of electricity annually, resulting in annual emissions of 39.8 MT/CO2. On the other hand, the use of Bitcoin mining to utilize excess energy from renewable sources could potentially provide a sustainable solution to the environmental issues surrounding Bitcoin. But what's even more intriguing is the fact that the shift from coal resources in China to coal resources in Kazakhstan has actually increased Bitcoin's carbon footprint due to the higher carbon content of Kazakhstani coal. The contradictions and complications surrounding the environmental impact of Bitcoin mining are a perfect example of the complexities of the e-waste crisis. As we strive to balance our desire for innovation and progress with the need to protect the environment, it becomes clear that there are no easy solutions. The midpoint of our journey to uncover the truth about the e-waste crisis reveals a stark reality. The tech industry's addiction to innovation and growth has led to a culture of disposability, resulting in a staggering amount of electronic waste. But it also highlights the potential for sustainable solutions, such as the use of Bitcoin mining to utilize excess energy from renewable sources. As we move forward, it's essential to consider the broader implications of our actions and the consequences of our addiction to technology. The question is, can we find a way to balance our desire for innovation and progress with the need to protect the environment, or will we continue to prioritize short-term gains over long-term sustainability? The environmental impact of AI is another crucial aspect of the e-waste crisis that cannot be ignored. The design, training, deployment, and use of artificial intelligence have significant environmental implications, including greenhouse gas emissions from generating electricity for data centers and computing hardware, operational and upstream water use, and material impacts from hardware manufacturing, mining, and electronic waste. Estimating AI's environmental effects can be difficult, as results depend on how impacts are measured, including whether accounting includes only model computation or also data center overhead, idle capacity, hardware manufacture, and local electricity supply. However, studies have shown that individual AI models can have significantly different energy consumption profiles, with some models using as little as 0.002-0.007 Wh per prompt, while others can use up to 11.49 Wh per image. But what's even more striking is the fact that software and infrastructure improvements can reduce energy use by a factor of 33 and carbon emissions by a factor of 44 for a typical prompt over 1 year. As we delve deeper into the world of AI and its environmental implications, it becomes clear that the issue is far more complex than initially thought. The rapid growth of the tech industry has led to a significant increase in energy consumption, with data centers and computing hardware being major contributors to greenhouse gas emissions. However, the use of AI can also provide sustainable solutions, such as optimizing energy consumption and reducing waste. The key to unlocking these solutions lies in understanding the environmental implications of AI and taking a holistic approach to addressing the e-waste crisis. But that's not the only challenge. The lack of standardization in e-waste management and the lack of transparency in the tech industry have made it difficult to track the environmental impact of AI and other technologies. As we move forward, it's essential to prioritize transparency and accountability in the tech industry in order to ensure that our desire for innovation and progress does not come at the cost of the environment. As we delve deeper into the world of e-waste and the environmental impact of the tech industry, it becomes clear that the problem is far more complex than initially meets the eye. The rapid advancement of technology and the constant demand for newer, better, and faster devices have led to a staggering amount of electronic waste. In 2022, a staggering 62 million tons of electronic waste were generated globally, with only 3% being formally collected and recycled. This not only poses a significant threat to the environment, but also to human health, as the informal processing of e-waste in developing countries can lead to the release of toxic materials such as lead, cadmium, and brominated flame retardants. But that's not the only concern. The production of new devices, particularly those required for Bitcoin mining, has led to a significant increase in energy consumption and greenhouse gas emissions. According to the 2025 Cambridge Digital Mining Industry Report, Bitcoin mining consumes a vast amount of electricity, with 48% of it coming from fossil fuels and 52% from sustainable energy sources. This has resulted in Bitcoin's carbon footprint being compared to that of a small country, with annual greenhouse gas emissions of 39.8 mt CO2. The environmental impact of Bitcoin mining is further complicated by the fact that the majority of mining operations have shifted from China to countries like the United States, Kazakhstan, and Russia, where the energy mix is often more carbon-intensive. The use of specialized computer hardware for Bitcoin mining has also led to a significant amount of electronic waste. As the hardware physically degrades through use, it becomes obsolete and is often discarded, contributing to the already staggering amount of e-waste. In fact, it's estimated that the production of new devices, including those used for Bitcoin mining, will lead to a significant increase in e-waste generation, with global e-waste production projected to reach 82 million tons by 2030. This raises important questions about the sustainability of the tech industry and the need for more responsible and environmentally friendly practices. But what's often overlooked in the conversation about e-waste is the impact of individual devices and the energy they consume. A benchmark study presented at the 2024 ACM Conference on Fairness, Accountability, and Transparency found that the energy use per AI request can vary widely, with some tasks consuming significantly more energy than others. For example, image generation can use up to 11.49 Wh per image, while text generation and text summarization use significantly less energy. This variability in energy consumption highlights the need for more efficient and sustainable technologies, as well as greater transparency and accountability in the tech industry. As we consider the environmental impact of the tech industry, it's essential to examine the role of governments and regulators in addressing the issue. In recent years, there has been a growing trend towards greater transparency and accountability, with many countries implementing data center reporting requirements, energy efficiency standards, and broader transparency measures for AI-related resource use. However, more needs to be done to address the scale and complexity of the problem. The European Union, for example, has classified e-waste into 10 categories, including used electronics destined for reuse, resale, salvage, recycling, or disposal. This classification system highlights the need for a more nuanced and comprehensive approach to addressing the environmental impact of the tech industry. But that wasn't the strangest part. As researchers have delved deeper into the world of e-waste, they've discovered that the problem is not just about the devices themselves, but also about the materials used to make them. Many electronic devices contain potentially hazardous materials, such as lead, cadmium, and brominated flame retardants, which can have serious environmental and health impacts if not disposed of properly. In fact, it's estimated that around 70% of toxic waste in landfills is electronic waste, despite e-waste accounting for only a small percentage of total waste. This highlights the need for more responsible and sustainable practices throughout the entire life cycle of electronic devices, from production to disposal. As we move forward, it's clear that the environmental impact of the tech industry is a complex and multifaceted issue, requiring a comprehensive and nuanced approach. The production of new devices, the energy consumption of individual devices, and the disposal of electronic waste all contribute to a significant environmental footprint. But by prioritizing transparency, accountability, and sustainability, we can work towards a more environmentally friendly and responsible tech industry. The question is, will we be able to make the necessary changes before it's too late? Or will the environmental impact of the tech industry continue to escalate with devastating consequences for our planet? The answer remains to be seen, but one thing is certain: the future of our planet depends on it. As we delve deeper into the environmental impact of the tech industry, it becomes increasingly clear that the e-waste crisis is just the tip of the iceberg. The production and disposal of electronic devices, from smartphones to computers, are contributing to a staggering amount of waste, with only 23% of the 62 million tons of electronic waste generated in 2022 being formally collected and recycled. But that's not the only concern. The extraction of rare earth metals and other materials necessary for the production of these devices is also having a devastating impact on the environment. For instance, the mining of cobalt, a key component in lithium-ion batteries, has been linked to human rights abuses and environmental degradation in countries such as the Democratic Republic of Congo. But what's even more alarming is the role that artificial intelligence is playing in this crisis. As AI technology continues to advance, the energy required to power these systems is increasing exponentially, with some estimates suggesting that the carbon footprint of AI could be as high as 2.5 times that of the entire aviation industry. And it's not just the energy consumption that's the problem. The production of AI hardware, such as graphics processing units, is also generating a significant amount of e-waste. In fact, a study by the University of Michigan found that smaller language models use about 114 joules per response, while larger models require up to 700 joules per response, which is equivalent to the energy needed to run a microwave oven for roughly 1/10 of a second and 8 seconds, respectively. As we consider the environmental impact of AI, it's also important to look at the role of Bitcoin and other cryptocurrencies in this crisis. The energy required to mine Bitcoin, for example, is staggering, with estimates suggesting that it consumes around 138 TWh of electricity annually, which is comparable to the energy consumption of a small country. And it's not just the energy consumption that's the problem. The e-waste generated by Bitcoin mining is also a significant concern. In fact, a study found that the average lifespan of a Bitcoin mining machine is around 1.5 years, after which it becomes obsolete and is discarded, contributing to the already overwhelming amount of e-waste. But that wasn't the strangest part. As we dug deeper, we found that the environmental impact of Bitcoin mining is not just limited to the energy consumption and e-waste generation. The mining process itself is also having a devastating impact on local ecosystems. For example, in Kazakhstan, where a significant amount of Bitcoin mining is taking place, the coal plants used to power the mining operations are releasing large amounts of toxic pollutants into the air, contributing to severe air pollution and health problems for local residents. And in the United States, where Bitcoin mining is also on the rise, there are concerns about the impact of mining operations on local water sources and ecosystems. As we consider the complexities of this crisis, it's clear that there are no easy solutions. But one thing is certain: the tech industry must take responsibility for its environmental impact and start making changes. This could involve investing in renewable energy sources, reducing e-waste generation, and developing more sustainable technologies. For instance, companies like Google and Microsoft are already taking steps to reduce their carbon footprint by investing in renewable energy and implementing sustainable practices in their operations. However, more needs to be done, and it needs to be done quickly. The question is, what will it take for the tech industry to make a significant change? Will it take government regulation, consumer pressure, or something else entirely? As we look to the future, it's clear that the environmental impact of the tech industry will only continue to grow unless drastic action is taken. And the consequences of inaction will be severe, from devastating environmental degradation to significant human health impacts. The clock is ticking, and it's up to us to demand change. But as we wait for that change to happen, we can't help but wonder what other secrets is the tech industry hiding, and what will be the true cost of our addiction to technology.